Hello everybody. This is my video from my house. I tried to record this at school and it messed up a whole bunch, and so I just got mad and decided to do it again at my house. So this is for my 6th hour, you all who were not here on Monday, which was all of you. And so we did an assignment on Monday, which if you happen to have your book at your house and you want to try to keep up with us, you can do it. But if you don't have your book because it's at school, that is completely fine. You don't have to do it. But this is just for people who maybe really want to know what we did on Monday, so you're not confused later. So even if you don't have your book, please watch the whole video and just maybe you can learn what we did just by watching it. But if you do have your book and you can follow along, we're going to be doing page 54. What we did in class was we did page 54 all together, and then the assignment was page 55. We did all of page 55, which is number 1 to 11. And so if you were just curious, hey, what did I miss on Monday? This is what you missed. But I know that some of you may have your book at school. So if you just need to watch it because you don't have your book with you, that's fine as well. So we spent Monday talking one more time about scientific notation. I believe we talked about this on Friday before we got out early for homecoming, maybe even a little bit on Thursday. So these first few may be a little bit of a review questions, but hopefully they will be good ones for you. They're going to start out on these first two with numbers in scientific notation. Remember, scientific notation has some very specific rules. This first number has to be in between 1 and 9.99999, right? It has to be 1 in between 1 and 10, and it's usually a decimal. It doesn't have to be. And then it's always multiplied by 10 to a certain power. And that exponent right here tells you how many places to move the decimal. For example, if I go on number 1, this is number 1 on page 54. If I take the decimal 9.931, it's in between 1 and 10, so that's cool. And this is telling me it has an exponent of 5. This is being multiplied by the number 10 5 times in a row. And what that's really going to do is that's going to make this number bigger, right? And so when this exponent on the 10 is a positive number, you're going to make your number bigger by moving the decimal to the right. And so we're going to move it 5 places. 1, 2, 3, 4, 5. You've got a few empty spots there where you need to fill in, and we're just going to fill those in with zeros. 1 right there, 1 right there. Now, I shouldn't probably circle my answer the way that it looks right now because that looks kind of icky. I got it all different colors. I got these loops underneath it. So I'm going to go ahead and rewrite it like a nice, neat answer would look. 993100. You can put your comma in there if you want to, but you don't have to. That is how you take a number in scientific notation and write it in standard form. This is called standard form. All that means is it's written like a normal number. It's the standard. All right, now number 2 is a little bit different, and I think we've talked about this already, so that hopefully this is an easy one. Look at number 2. We have a decimal between 1 and 10. Okay, that looks good. Multiplied by 10. That looks normal. But now look, the exponent is -4. What this really means is we are dividing this number by 10 4 times in a row. We're multiplying it by 1/4, or no, 1/10 4 times. That's the same thing as dividing by 10 4 times in a row. So now I need to do something differently, don't I? Since this is a negative, I don't want to make this number bigger. I want to take this decimal and I want to make it smaller. I want to move the decimal to the left. And so I'm still going to move it 4 places because this is a 4, but now I'm going to move it 4 to the left because I'm going the other way. 1, 2, 3, 4. And there you go. My loops aren't looking very good. They're getting kind of awkward there and all kind of squiggly. But 1, 2, 3 little zeros can fit in there. That looks a little bit strange and messy, so let me kind of clean it up a little bit, write it like a nice, neat answer. Decimal point 0.00602. That is the same thing as this, right? So whenever we do these problems, we're not changing the number. This is the same thing as this. It's just a different way of writing it. Standard form, scientific notation. All good on those? Okay, so these 2 questions will help you on page 55. If you chose to do page 55, this is going to help you with number 1, 2, and 3 on page 55. 1, 2, and 3 are just like these. So if you want to pause the video, go ahead and do number 1, 2, and 3 on page 55. Go ahead and pause it right now, and then unpause it when you're done. All right, if you're just going to watch the whole thing because maybe your book isn't with you, now we also get to do some in the reverse order, right? Now look what we have. On 3 and 4, we have numbers that are already in standard form. Those are already normal numbers, and we need to take them and write them in scientific notation, right? I think we might have done this before the weekend. We're going to need to put a decimal right here. We know it's going to be multiplied by 10, and we also are going to need an exponent, right? We're going to have to kind of fill in some numbers in these boxes. So the first thing we need to do is move the decimal point. Excuse me? Do you even see a decimal up there at all? I don't even see a decimal point. There isn't one. Those are all commas, right? So if they don't put a decimal, you got to put it all the way at the end, all the way to the right. And we're going to move this decimal a certain number of times. We saw Tim and Moby do this on the video when we watched the BrainPop video, right? How do I know when to stop? Do I just keep going as long as I want to? Do I just stop right here when I'm done with all the zeros? No. You want to stop whenever you get, remember, this has to be in between 1 and 10. If I stop right now, look what I have. I have 8,785. That number is way too big. That is not in between 1 and 10. So I need to keep going. That's not good enough. If I stop right here, not good enough, because look what I would have. 878.5. Nope, still too big. I got to get it in between 1 and 10. If I go to right here, 87.85. That's not good enough. That's still bigger than 10. I need to go all the way to right there, 8.785. And you don't have to put all those zeros at the end. 8.785. This number has to be between 1 and 9.99999, right? It cannot be bigger than 9.999 repeating bar. So this is in between 1 and 10. I did it right. Now I need to figure out the exponent. Okay, common sense question here. Should this exponent be positive or negative? Think about the number that we started with. 8,785,000,000. That is a big number. If you have a big number, you better have a positive exponent right here. This is going to be a positive number because look how big this is. So let's count how many places we moved it. We're going to count my little loops here. Count how many places we moved the decimal. 1, 2, 3, 4, 5, 6, 7, 8, 9. I counted 9. Positive 9, because this is a big number. Any number that's bigger than 10, it's bigger than our limit. It's going to have a positive exponent. Okay, that's number 3 on page 54. It will help you on page 55 with number 4. Number 4 on page 55 is just like this. Okay, now what if they give us a really tiny number to start out with? Like, look how tiny this one is. This is 0.524. This number is smaller than 1. That's going to be a little bit different than the last one, right? I'm still going to do a decimal between 1 and 10. I'm still going to have it multiplied by 10, and I'm still going to have an exponent, but now I'm going to have to take my decimal and move it the other way. Right? If I move the decimal to the left on this one, am I ever going to get a number between 1 and 10? No, I'm going to have 0, 0, 0, 0, 0. I'm never going to get a number between 1 and 10. So what I need to do is move the decimal the opposite direction. And, oh, hang on. Did I just do it? Is that it? This is in between 1 and 10, right? 5.24. Yeah, we just did it. 5.24 is it. That's a decimal right there. 5.24. If I would have kept going, look what I would have had. If I stopped right here, that would be 52. Nope, that's way too big. 52.4 would be too big. So it's 5.24. Now, how many places did I move it? 1. But let's use common sense. Should this be positive or should this be negative? Look at the number we started out with. We started out with 0.524. If it's a number that's smaller than 1, right? Our limit is in between 1 and 10. If it's lower than the limit, it's got to be negative. If it's a tiny, 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 tiny decimal, it better be negative because the whole number is really, really small. All right? That's number 4 on page 54, and that should help you with number 5 and 6 on page 55. On page 55, number 5 and 6 are just like this one. So you can pause the video if you want to. Go do number 5 and 6, and then unpause it whenever you're done. Alrighty. If you're unpaused and now you're ready for the next question, number 5 on page 54, this is my favorite one because it looks really hard, but it's not really even hard at all. In fact, it's easier than all the ones we've already done. On number 5, it asks us to take this table. It shows how much money people made selling music in 4 different years. Year number 1, year number 2, year number 3, year number 4. Here's how much money they made. And look, they made a ton of money. Holy cow. If I had to remove the decimal 10 places, that would have a whole bunch of zeros on it. That'd be like $1 billion some dollars. But they want us to put these in order from least to greatest. Okay, this is kind of a trick question. They've set a trap for you right now. They have just set a trap and they're waiting for you to walk right into it and look like a complete moron so they can laugh at you. But we're not going to fall for their tricks. What trick did they set for you? They've tried to trick your eyes, so to speak. They want you to look at the decimals and say, okay, least to greatest. I know how to do that. I've done that in elementary school. They want you to say, okay, 1.22, 1.12, 7.15, 1.06. They probably want you to say this is the smallest because it's the smallest decimal. And then you would say that one, and then you would say that one, and then you would say this is the biggest. But that is not correct. Don't look at the decimals. Look over here at the exponents, right? Look at this, right? Look over here. This is where you should be looking. Look at the exponents. That is going to tell you the first part. That's going to tell you which number is the smallest and which number is the biggest. Don't look at the decimals. That's going to be a trick. You want to look here, 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 and here. Which one of those is the least? Boom, 6, right? 10 to the 6th power is a whole lot smaller than 10 to the 10th or 10 to the 7th. So this is actually the smallest. Do you see how that would have fooled people? If they didn't know to look at the exponents first, I bet a lot of you would have picked this one because it started with a 7, and you would have thought that's the biggest one, but it's actually the smallest one because it's 10 to the 6th. And then guess what's going to be next? If this is the smallest, because it's 10 to the 6th, then 10 to the 7th should be next. So year number 4 is next. And now these two are tied. These two at the top are both 10 to the 10th, right? Here and here. If you have a tie, now it's when you should be looking at the decimal. Don't even look at the decimals until you get a tie. And now that we see we have 10 to the 10th and 10 to the 10th, now we can compare. Okay, since they're tied on their exponents, now which decimal is smaller? 1.22 or 1.12? And obviously this, $1.12, year number 2, is smaller. So this guy is actually number 1. That's the biggest. Year number 1, they sold the most. So did you see how we did that? Don't get tricked into being lazy and just look over here first. No, 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 no. Look at the exponents first and do those in order. And then if you have any ties, you can break the tie by looking at the decimals. But the decimals are only to break the ties. Use the exponents. Whether you're going least to greatest, like this one, or greatest to least, it doesn't matter. Always, always, always look at the exponents first. Okay, so that's number 5 on page 54. It matches up perfectly with number 7 on page 55. So if you want to pause the video right now, pause it, go do number 7 on page 55 if you have your book, and then come back. All right, and if you're back or if you never left, now we have number 6 on page 54. This will be the last one we really need to do on page 54. They give you a real-world scenario, and they ask you which measurement is more reasonable, which measurement makes more sense. Now, technically, these are the exact same number. This and this are the exact same measurement. They're just saying it different ways, right? You know what I mean when I say the same thing? Like if I said I bought 12 donuts at Casey's, or then the next day I come in and I say I bought a dozen donuts at Casey's, isn't that representing the same amount? A dozen and 12 are the same thing, right? These are the same thing. It's just that they wrote it using different measurements. Right? If I said, "Oh, I'm growing a plant for ag, and my plant for ag is 12 inches tall," and then another person comes in and says, "Well, mine is 1 foot tall." It's the same thing, right? This is the same measurement, but which one makes more sense? Okay, this doesn't take a calculator. This doesn't take anything except for common sense. Look at what we're describing here. This is a plant cell. The diameter of a plant cell, not a plant itself. One cell. Could you even see a cell? No, you can't. You're going to need a microscope. It's so tiny. So let's just use common sense. If I'm measuring a cell of a plant that is very tiny, I have to have a microscope. Should I be using kilometers to measure that? Or should I be using millimeters to measure something that's very small? Which one of these would make more sense to measure something really small? And if you don't know, what is a kilometer? A kilometer is pretty close to a mile. It's not exactly a mile, but it's pretty close. So like think about the distance between Beeger Middle School and Dairy Queen. Would you want to measure an itty-bitty plant cell with something that's the size of the distance between Beeger Middle School and Dairy Queen? No, that would be way too big. Why would you pick that? That doesn't make sense. Would you measure something that's really itty-bitty small with a millimeter? Do you know what a millimeter is? It's like this much, the distance between my fingers. Maybe, right? That is a very tiny measurement, right? This is very small. Millimeters are small. Kilometers are big. So if I have something small like a plant cell, I want to pick the small measurement, right? If I had something big, like if this question, instead of being a plant cell, if it was how far the distance between the Earth and the Moon, then I would maybe do kilometers because that's a long way. Or the distance between Marshall, Missouri and Kansas City, yeah, then I would measure it in kilometers. But if you have something that's tiny, measure it in the tiny measurement, right? It's just common sense. Like if you walked around, if I asked everyone how old they were, you're going to tell me, oh, I'm 13 years old, I'm 14 years old. No one is going to walk up to me and say, oh, I'm 3 billion seconds old. Like who measures your age in seconds? No one. Or who would measure it like in centuries? I'm 0.12 centuries old. No, people would look at you like you're weird if you did that. So